Okay, in this video I'm going to be talking about a basic definition of acids and bases, and then I'm going to go to a slightly better definition of acids and bases that was introduced by Bronsted and Lowry. So the most basic idea here is an acid is something that raises the amount of hydrogen in water. And if you raise the amount of hydrogen that exists in the water, you're going to lower the amount of hydroxide that exists in the water at the same time. Alternatively, a base is something that raises the amount of hydroxide in the water, and as a result will lower the amount of hydrogen in the water. So acids make it more hydrogen in the water, and bases make it less hydrogen in the water or more hydroxide in the water. With that in mind, Arrhenius came up with a pretty simple definition of an acid. An acid is something that can dissociate in water to put hydrogen into the water. And our common examples here, hydrochloric acid, sulfuric acid, nitric acid. So hydrochloric acid, for example, if that broke down as a salt, would form H plus and Cl minus. And obviously this would be more hydrogen in the water. And a base as a salt that contains hydroxide, and so when it dissolves in water, it naturally raises the amount of hydroxide in the water. So that's our very simple definition that we got from Arrhenius. This definition was pretty good, but it was flawed in two specific ways. Where'd we go here? Bronsted and Lowry were two scientists working together, and they did a couple of things to improve our understanding of acids and bases. First of all, they recognized that HCl as a solid not dissolved in water doesn't act as an acid. Instead, it looks like a salt. And so what they realized is that water as the solvent for any acid or base must play a role in the properties of that substance being an acid or a base. So Bronsted and Lowry took into account the role of water as the solvent in an acid. Secondly, they recognized that if this was aqueous and so broke down into H plus and Cl minus, in the real world H plus ions, or just a proton like that, doesn't just exist on its own in water, but instead that H plus ion will find a water molecule, and it will actually covalently bond onto one of the spots with the water and form the polyatomic ion hydronium. So H plus doesn't exist on its own in water, but instead it takes on this bonding site on a water molecule and forms hydronium, this polyatomic. Within that, then, they reframed the idea of acids and bases as acids being things that donate protons to water, and bases being things that accept protons from water. And keep in mind here, hydrogen and protons, that's the same thing, right? Because a hydrogen is just one proton. So here, they would have adjusted their idea of how hydrochloric acid behaves as an acid to show it reacting with water, taking into account water as the solvent, and it would produce Cl minus and hydronium. And so the way we can look at this is this acid has donated its hydrogen atom to the water to form hydronium. On the other hand, if we take something like a base, like water, or like, well, the real advantage of this approach is it allowed us to identify a number of bases that we didn't think of as bases because they did not directly involve hydroxide. So for example, we can take the base ammonia. Ammonia reacts by accepting a proton from the water molecule to form ammonium. And when it does that, the water is left as a hydroxide, having given up one of its protons. So here, another big advantage of the Bronsted-Lowry definition of acids and bases is that we identified some acids and bases that we didn't otherwise see having that property. And one example of that is ammonia. A base, as a proton acceptor, takes the hydrogen from the water, making ammonium, the polyatomic, and as a result, raising the amount of hydroxide in the water. So, if we go back and adjust our original definition as raises the amount of hydronium in water and hydroxide in water, then what we can see is to raise the amount of hydronium, an acid donates a proton to make hydronium, and alternatively, to raise the amount of hydroxide, a base accepts a hydrogen from water, leaving more hydroxide after the reaction. So that's a slightly better definition of acids and bases. There are more complex definitions of acids and bases, but that's as far as we're going to go in this course.